We'll start from solving first degree equations in one variable. Then we will see solving second degree equations in one variable. Then we will discuss about inequalities and their solutions. What are inequalities? What is the interval notation? How to solve inequalities and how to solve the second degree inequalities. Dear students, we start from equations and their properties. A statement of equality of two algebraic expressions which involves one or more variables and constants is called equation. Following are the examples of equations. Number 1, x is equal to 5 is an equation. Similarly, x plus 2y square is equal to 10 is another equation. Standard form of linear equation in one variable is given by ax plus b is equal to 0, where a cannot be 0. Dear students, now we discuss the types of equations. Equations are basically of three types. Number 1, identity equation. Number 2, conditional equation. And number 3, false statement or contradiction. First of all, we define identity equation. So it is an equation in which we have the form 3 times x plus y, which is equal to 3x plus 3y. Second type of equation is called conditional equation, and its definition is that for special values of our variable, for example 2x is equal to 5. The third type of equation is called false statement or contradiction. So it is not true for any value of the variable x. For example, if we write x is equal to x plus 1, then this is not true for any value of x. For example, if we put x is equal to 1, so we get 1 is equal to 2, which is not true because 1 is not equal to 2. Dear students, now we solve a linear equation. Example, solve the given equation 2x minus 3 is equal to 7. First step, add 3 on both sides of the given equation. We get 2x minus 3 plus 3, which is equal to 7 plus 3. So we get 2x is equal to 10. Now dividing by 2, we get x is equal to 10 over 2. So x is equal to 5 is the solution of the given equation. Dear students, consider the second example. Solve the given equation x over 2 minus 1 is equal to x over 3 plus 1. First of all, we arrange the given equation and then we try to solve it. So we get x over 2 minus x over 3 is equal to 1 plus 1. Now we take LCM of 2 and 3, which is 6. So we get 3x minus 2 over 6 is equal to 2. That is, after simplification, we get x over 6 is equal to 2 and x is equal to 6 times 2, which is 12. So the solution of the given equation is x is equal to 12. Dear students, you can see that if you put x is equal to 12 in the given equation, you get both sides equal. So in this way, you can also check the solution. Dear students, now we see the solution of second degree equations in one variable. First of all, we define an equation which contains exactly one variable that is squared. A quadratic equation is an equation of the second degree in one variable. Standard form of quadratic equation is given by ax square plus bx plus c is equal to 0, where a cannot be 0. Dear students, now we see the method to solve quadratic equations. For example, if we have x square plus 2x minus 3 is equal to 0, then the solution means the roots of this equation ax square plus bx plus c is equal to 0. First, we see the discriminant, which is denoted by b square minus 4ac. Dear students, if discriminant b square minus 4ac is greater than 0, then there will be two distinct and real roots. If discriminant b square minus 4ac is equal to 0, then there will be two equal and real roots. And lastly, if discriminant b square minus 4ac is less than 0, then there will be no real root. Dear students, there are three methods to solve quadratic equation. The first one is called quadratic formula, the second is called factorization method, and the third is called completing square method. Dear students, now we solve the given equation using quadratic formula. We have the quadratic equation x square plus 2x minus 3 is equal to 0. Using the quadratic formula, that is given by x is equal to minus b plus minus b square minus 4ac square root divided by 2a. Now from the above equation x square plus 2x minus 3 is equal to 0, we can see that a is 1, which is the coefficient of x square, b is 2, which is the coefficient of x, and the constant term is c equal to minus 3. So substitute these values in the quadratic formula, we get that x is equal to minus 2 plus minus 2 square minus 4 times 1 multiplied by minus 3 square root divided by 2 into 1. So after simplification we get x is equal to minus 2 plus minus 4 plus 12 square root divided by 2. That is x is equal to minus 2 plus minus 16 square root divided by 2. So we get x is equal to minus 2 plus minus 4 over 2. So we get x is equal to minus 2 plus 4 over 2, or the second value is x is equal to minus 2 minus 4 divided by 2. So after simplification we get x is equal to 1 or x is equal to minus 3. So the solution set consists of two values of x which are given by x is equal to 1 and x is equal to minus 3. Dear students, now we solve the same quadratic equation using the factorization method. First, we factorize the given equation. For this factorization method, we take the coefficients of first term and third term. So we get 1 multiplied by minus 3, which is equal to minus 3. So we divide this 2x, the middle term, into two parts such that we get 3x minus x, which is 2x. So our given quadratic equation is x square plus 3x minus x minus 3 is equal to 0. So if we take x common from the first two terms, we get x into x plus 3, and if we take minus 1 from the last two terms, we get minus 1 times x plus 3 is equal to 0. So we get x plus 3 multiplied by x minus 1 equal to 0. Now the product is 0, therefore x plus 3 is equal to 0 or x minus 1 is equal to 0. So now solving both the parts separately, we get x plus 3 is equal to 0 or x minus 1 is equal to 0. It gives x is equal to minus 3 or x is equal to 1. So we can see that the solution set consists of x is equal to 1 and x is equal to minus 3. Dear students, now we solve the same quadratic equation by using the third method, which is called the completing square method. So we have two quadratic equation x square plus 2x minus 3 is equal to 0. First, we make the given equation in the form of completing square by adding, subtracting 1 in the given equation. That is, we write x square plus 2 times x into 1 plus 1 square minus 1 square minus 3 is equal to 0. Dear students, in this step, we have added 1 and subtracted 1. So the overall there is no effect on this equation, and we get the first three terms as complete square, which is given by x plus 1 whole square. Then we have minus 1 and minus 3. Then we have minus 1 and minus 3 equal to 0. So we get x plus 1 square minus 4 is equal to 0. So we get x plus 1 square is equal to 4, and taking square root on both sides, we get x plus 1 is equal to plus minus 2. So solving this, we get x plus 1 is equal to 2 or x plus 1 is equal to minus 2. So solving these two parts, we get x is equal to 1 or x is equal to minus 3. Therefore, the solution set by the completing square method is given by x is equal to 1 and x is equal to minus 3. Dear students, you can see that by applying these three methods, we get the same solution for the quadratic equation. Whether we apply completing square method, whether we apply quadratic formula, or we use the factorization method. Dear students, now we define inequalities. Inequalities are the conditions in which two quantities are not equal. They may be greater or less than each other. There are special symbols which show that in what way quantities are not equal. Consider A and B as two quantities. Then A with this symbol B means that A is less than B, and A with this symbol B shows that A is greater than B. Dear students, now we discuss about the types of inequalities. There are three types of inequalities. The first one is called absolute inequality, and for example, you can see 2 less than 6. The second is called conditional inequality, and it is true for certain values of x. For example, if we say 2x is less than 6, then if we take x is equal to 1, then this inequality is true. But if we take x is equal to 5, so we get 2 into 5, 10, that is not less than 6. So this inequality is not true. So these type of inequalities are true conditionally. The third type of inequalities is called double inequality, in which we bound x from both sides. For example, here we say 2 is less than x and x is less than 6. So here the x is bounded from both sides. So there are two bounds on x. So we get the double inequality. Dear students, now we define interval notation. Let x be the set of real numbers that lie between two numbers a and b, and it is called an interval. This can be specified using the following notation. We write a comma b and put the parenthesis. This is called open interval a to b. And this is by definition equal to x, such that x is greater than a and x is less than b. Dear students, intervals are basically of four main types. Number one, open interval. It is represented as parenthesis a to b, and it has endpoints a and b, but this interval does not include the endpoints. For example, if we take the open interval 2 to 5, which can be represented as x, such that x is strictly greater than 2 and x is strictly less than 5. So all the points between 2 and 5 are included, but 2 and 5 itself are excluded. Second type is closed interval. So we represent it as parenthesis a to b, and it has endpoints a and b, and closed interval means it includes the endpoints as well. For example, if we write 2 to 5 closed interval, so it is represented as x, such that x is equal to or greater than 2 and x is less than or equal to 5. So the closed interval 2 to 5 contain all the points between 2 and 5, and it also contains the endpoints which are 2 and 5. Dear students, now we define half open interval. It includes one endpoint, but it does not include the other endpoint. For example, if we write 2 to 5 and it is open from 2 and closed from 5, so it contains 5 but it does not contain 2, so it is called half open interval. Similarly, we can write half closed interval. It also includes one endpoint, but the other endpoint is not included. For example, if we write 2 to 5, 2 is closed interval and from the 5 side it is open interval, so it is called half closed interval. It contains 2 but 5 is not included. Dear students, now we see how to solve the inequalities. Consider the example. Determine the values of x which satisfy the inequality 2x minus 5 is greater than or equal to 7. Here we add 5 on both sides of the given inequality. So we get 2x minus 5 plus 5 is greater than or equal to 7 plus 5. So we get 2x is greater than or equal to 12. Now we divide both sides by 2. So we get 2x over 2 is greater than or equal to 12 over 2. It means that x is greater than or equal to 6. For all values of x greater than or equal to 6, x satisfies the given inequality. Dear students, you can check by putting x is equal to 7, for example, in this inequality. You will see that the inequality is satisfied. Dear students, now we solve second degree inequalities. Example. Solve the quadratic inequality x square plus 4x minus 12 is less than or equal to 0. To solve the quadratic inequality, we have to break the middle term using the factorization method. So we break the middle term, which is 4x. So we break it into two parts, which is 6x and minus 2x. So we get x square plus 6x minus 2x minus 12 is less than or equal to 0. So we take x common from the first two terms. So we get x into x plus 6. Similarly, we take minus 2 common from the third and fourth term. So we get minus 2 into x plus 6 is less than or equal to 0. So writing in the product form, we get x plus 6 into x minus 2 is less than or equal to 0. This implies that we have two cases. The first case is x plus 6 is positive and x minus 2 is negative. Because when the product of two numbers is negative, any number can be positive, and because when the product of two numbers is negative, first number is positive, second number is negative, or in the second case, first number is negative and the second number is positive. So therefore we get the first case x plus 6 is greater than 0 and x minus 2 is less than 0, or the second case will be x plus 6 is less than 0 and x minus 2 is greater than 0. Dear students, now we will solve both the cases one by one. First of all, see the case 1. When x plus 1 is greater than 0 and x minus 2 is less than 0, it means that x is greater than minus 6 and x is less than 2. So on the number line, it can be represented as, you can see the number line starting from 0 up till one side we have 1, 2, 3 up till 6, and on the other side we have minus 1, minus 2 up till minus 6. So on the top of this number line we represent x is greater than minus 6. So starting from this blank hole at minus 6, you have an arrow moving in the right direction. Similarly, the other inequality x is less than 2 is represented below this number line, and we have a blank hole at 2 and we have the arrow directing in the left side. So from these two arrows we can see the area which is common between both the arrows, and it is represented by these red lines. So here we have some common area between minus 6 and 2, and this minus area is the solution set, and it is represented as x such that x is greater than minus 6 and x is less than 2. So our solution set consists of all the points of x in the open interval minus 6 to 2. Dear students, now we consider the second case when x plus 6 is less than 0 and x minus 2 is greater than 0. Here we solve it and we get that x is less than minus 6 and x is greater than 2. As we have done in the previous case, similarly we will here represent our solution set on the number line. The number line is again given here, and you can see on the top of this number line is x is less than minus 6. So it is represented as blank hole at minus 6 and then an arrow moving in the left direction. Similarly, below this number line we have x greater than 2. It is represented as blank hole at 2 and arrow is moving in the right direction. So we can see from these two arrows there is nothing common. So we have when x is less than minus 6 and x is greater than 2, we don't have any area common between these two inequalities, and hence there is no solution set in this case. Dear students, so we have the solution set only in the first case, and that is represented in the form of open